Hi everyone. My name is Jordan Dimasangal and I am joined with my teammates namely Lemuel, Kingstone and Joey Moore. In today's presentation, we are going to talk about BIM and lean construction, how they work together to make big changes in construction industry. And that include how BIM, which was actually originally known for its role in creating 3D models, can help lean construction become even better. Before I go further, we need to understand first what is lean construction and BIM. So far, lean construction was presented already to us in class, so I will just give a brief description about lean construction. It's all about doing construction work efficiently, avoiding waste, and constantly working together to make things better, and of course, to keep the client happy. Uh, what about BIM? BIM, which stands for Building Information Modeling, is basically a digital representation of a building or infrastructure. Whether you're new or experienced to a construction, visualizing an entire project can be difficult, right? So it's hard to picture how it will all come together, especially if you are planning your first development project and you are not yet familiarized with the construction practices. So the rise of virtual building design has made this simpler, allowing simulation of how a fully constructed building will look like on the inside and from the outside. So virtual design has evolved to a point where multiple designs can be integrated into a single 3D model, which can also simulate not only construction, but also operations and maintenance. So this concept is called Building Information Modeling or BIM. It also gives developers and contractors a better understanding of concepts compared with the conventional 2D drawings. So what does BIM plus lean construction equal to? BIM and lean construction are both impactful on their own, but when combined, they can create a powerful approach that reduces waste, enhances efficiency, and delivers better construction projects. BIM is considered one of the best resources for empowering lean principles. So how BIM relates to lean construction? We're going to start with the efficiency and value. BIM allows for the creation of a highly detailed 3D model that provides a visual representation of the project inside and out. So with this visual model, everyone that are involved can better understand what the final building will look like and how it will function. So it makes easier to deliver a value to the customer. Also can eliminate waste, generally by accurate planning. This reduces the likelihood of design errors and changes, which are a significant source of waste in construction. And the second one is clash detection. So BIM software can automatically detect clashes or conflicts in the design phase. The project is essentially about engineers, architects, contractors of different trades. However, when there are so many disciplines working together, clashes are inevitable. If not resolved, these clashes can result in reworks, which means wasted time, labor, and cost overruns. Uh, there's a study by McGraw-Hill. Uh, they found out that 75% of contractors said BIM was the most useful platform for them in identifying the clashes and resolving them with the alternatives. So another principle of lean construction is pool planning, where BIM can play a crucial role in supporting this principle. By adding an additional layer of scheduling information to a project, you can incorporate the time component into the 3D model. This is known as the 4D modeling. 4D BIM enables the visualization of each project stage, making project scheduling and sequencing much easier to understand, plan, and manage. It is like making sure you put on your shoes before your socks. Otherwise, it doesn't work. Next is respect for people. By providing a shared space for collaboration, BIM promotes mutual respect by acknowledging the unique expertise and the importance of each individual's contribution to the overall success of a project. And the last one is continuous learning. Throughout the project life cycle, BIM enables the collection of extensive data, including project timelines, changes, cost tracking, and performance metrics. So it helps us identify bottlenecks and inefficiencies of areas of waste. Through all this, we can identify patterns and trends. So it ensures that lessons learned from previous projects are applied to the new ones, leading to higher quality outcomes. Now, I'd like you to hand over to my teammate Lemuel, who will take us to through a case study from Dammam, Saudi Arabia. Thank you so much.
Hi everybody, I'd like to thank Jordan for the kind introduction. Today, I'm excited to talk about Building Information Modeling, or BIM, and its role as a lean management tool in the construction industry. We've got an array of case studies to explore, and they all showcase how BIM, when utilized effectively, can significantly boost the construction efficiency. The focus of our discussion for the case study today centers around a particular case study conducted in Saudi Arabia, led by Eldip and his team. The study titled "Utilizing BIM as a Lean Management Tool in Construction Processes," which shed lights on how BIM can revolutionize the construction landscape. Now, why is this study so compelling and its findings? Well, it's because the results and conclusions offer valuable insights into how BIM can be harnessed to eliminate the waste and streamline various construction processes. By doing so, they not only make construction projects more efficient but also reduce costs, which is critical consideration in any construction endeavor. This study aims to illustrate the potential of BIM in making construction projects more efficient and lean. The research selected a project at the University of Dammam in Saudi Arabia, which did not initially use BIM or land management tool, in order to understand the practical challenges and investigate BIM's role in enhancing lean principles. The study involved applying various lean and BIM techniques such as 3D digital workflows, collision detection, and direct fabrication from BIM during the design and execution phases. The goal was to explore the benefits of integrating BIM and lean through a real project and share insights gained. This study is part of a broader effort to develop an innovative information flow process model for BIM lean projects. The conclusion of this study found out that the building information modeling helps eliminate many waste during the construction process, such as design errors, poor communication, and unexpected changes in the design during execution. BIM enables creating an accurate model rich in information and free of clashes, which helps to make the right decisions during different construction stages. This study shows that implementing lean using BIM in the design works contributes significantly to the project's efficiency. BIM helped reduce the time required for the design progression to nearly 50% by reducing the waiting time waste. The BIM model can help save up to 1.5 months by removing the waiting time waste and achieving lean principles. On the other hand, design reviews and clash detections are the BIM-based technique in minimizing construction and design waste by eliminating errors detected in the construction. It can be said that through the BIM model, clash detection can save at least 3 weeks and 72,460 CAD at the university project, which results from the design errors. Even though eliminating all change orders that can arise at any project will be almost impossible, it seems that BIM can reduce the cost and the time change orders as a result of this study. The most significant reduction in change order was discovered when BIM was implemented on the project. Approximately 17 out of 20 change orders, or more than 80%, that belong to the owner-initiated changes and design errors change might be avoided using BIM model, making the projects more linear. BIM can cut costs by 11% and reduce the original project timeline by 25%. Well, These results or these findings of their study is very compelling to us since the results are very promising in the future, or yeah, we can use it today. However, there are some pros or cons in this kind of principle, which will be discussed by a colleague Joey.
Hello guys, Joey Mar here to discuss my part. Building Information Modeling or BIM is a digital representation of a building's physical and functional characteristics. It offers several advantages and disadvantages. Here are some of the advantages for using BIM. Improve collaboration. BIM facilitates collaboration among architects, engineers, contractors, and other stakeholders by providing a centralized platform for using information. This leads to better communication and coordination throughout the project. Visualization. BIM allows users to create 3D models to provide a visual representation of the project. This helps stakeholders to better understand the design, detect conflicts, and make informed decisions. Clash detection. BIM software can automatically detect clashes or conflicts in the design phase, reducing errors and rework during construction. This can lead to cost savings and faster project delivery. Efficient design changes. Making changes to the design in the BIM model is easier and less costly compared to traditional paper-based methods. This flexibility supports design iterations and improvements. Quantification and estimation. BIM can be used for accurate quantity takeoffs and cost estimation. This helps in budgeting and cost control during all phases of the project. Facility management. BIM models can be used for facility management, allowing owners to efficiently maintain and operate the building throughout its life cycle. Energy efficiency. BIM can help in energy analysis and simulation, enabling designers to optimize the building's energy performance. Sustainability. BIM can be used to assess the environmental impact of a building, helping in the design of more sustainable structures. Quality control. BIM allows for better quality control by providing a detailed and accurate representation of the building. This helps identify potential issues early in the design and construction phases. Documentation and record keeping. BIM serves as a comprehensive digital record of the project, including all design changes and modifications. This can be invaluable for legal and compliance purposes. Remote collaboration. BIM facilitates remote collaboration, allowing team members to work together from different locations, which can be especially useful during situations like the COVID-19 pandemic. Time savings. BIM can lead to time savings in the design and construction process by streamlining workflows, reducing errors, and enabling more efficient project management. Therefore, BIM offers numerous benefits in terms of collaboration, visualization, and efficiency, but it also comes with initial costs, a learning curve, and potential interoperability and security challenges that need to be carefully managed that will be discussed in the next slide. The decision to implement BIM should be based on the specific needs and constraints of the project and the organization involved. For the next slides, I will be discussing the disadvantages of using BIM. Initial costs. Implementing BIM can be expensive, including the cost of software, training, and hardware upgrades. Smaller firms may find it challenging to make this initial investment. Learning curve. BIM software requires a learning curve, and users need training to effectively utilize its features. This can slow down project adoption initially. Interoperability issues. Compatibility between different BIM software platforms can be a challenge. Projects involving multiple stakeholders with different software preferences may face interoperability issues. Data security. BIM models contain sensitive project information, and security is a concern. Protecting these models from unauthorized access and data breaches is critical. Maintenance and updates. BIM models must be maintained and updated regularly to remain accurate and useful throughout the project life cycle. Complexity. BIM can be overly complex for smaller projects, leading to unnecessary overhead and cost. Resistance to change. Some industry professionals may be resistant to adopting BIM due to the changes it brings to the traditional workflows. Complexity and training. BIM software and workflows can be complex, and it may require significant training and expertise to use them effectively. This can be a barrier for smaller firms or less experienced professionals. Data loss or corruption. Like any digital system, BIM models can be vulnerable to data loss or corruption, which can be catastrophic if not properly backed up or managed. Lack of standardization. There is no universal standard for BIM, which can lead to inconsistencies and interoperability issues when different software platforms or versions are used. Cost overruns. While BIM can help prevent some cost overruns through clash detection and accurate estimation, it can also lead to unexpected costs if not implemented and managed correctly. Legal and liability issues. The use of BIM can raise legal and liability issues, particularly when it comes to assigning responsibility for errors or omissions in the model. It is important to note that the advantages and disadvantages of BIM can vary depending on factors such as the size and complexity of the project, the experience and expertise of the project team, and the level of investment in technology and training. Organizations should carefully assess these factors when deciding whether to implement BIM and how to effectively integrate it into their processes.
Hello everyone, my name is Kingstone. In this slide, I will covering of some actual examples about BIM. Building information modeling has revolutionized the construction industry, offering innovative solutions and reshaping project approach. Some examples such as the Alto Tower, Oval Monitor Bridge, and Pedexo Dam. These cases highlight how BIM optimizes collaborations, accelerates timelines, and ensure efficient and facility operations, making it indispensable tool in modern construction practices. First is the Alto Tower. The Alto Tower in Paris, France stand out in the realm of building information modeling project due to its unique flared cone shape, spanning from floor to floor and tripling in size in its top floor compared to the ground floor. This distinctive design, dictated by limited ground spaces, showcases the exceptional use of BIM in both planning and construction processes. Second example is the Ovalum Monitor. The Ovalum Monitor Bridge project located in Peru stands as a testament to the power of cutting-edge technology, notably an impressive BIM software stack enabling the successful execution of monumental 870-meter vehicular bridge. It has a complex road design configuration with straight and curved sections. The bridge substructure is composed of two abutments and 21 piers. The superstructure is a continuous box section deck of post-tension concrete. Last is the Pedexo Dam. The Pedexo Dam in Indonesia, designed to prevent floods, utilized BIM tools to expedite the project significantly. By employing techless structures, BIM models, the project achieved faster shop drawing production, minimized rework, reduced material waste, and optimized natural resources. In the face of protests disrupting the project site, drone photogrammetry and BIM technology enabled precise existing measurements, ensuring the project progress remained accurate and efficient.